Yeah, we are live, Kaveri.
Okay. So should I speak now?
Yes, please.
Okay. Hello and welcome to the Citizen Science India 2021 virtual conference. This is the PM short talk session, and I'm your moderator, Kaveri Kargupta. I'll be moderating this session. All the videos will be available for later viewing on this channel. And thank you all for joining, and thank you all for all the speakers for this session. Each presenters will have a pre-recorded talk, and it will be streaming for 10 minutes. There will be 5 minutes of question, and at the end of each presentation, please ask your questions for speakers in the thread assigned to them. Thank you. Now to speaker Krishna Anujan. Let me talk a little bit about Krishna before she starts speaking.
Hi everyone, thanks for coming to my talk. My name is Krishna Anujan. I'm trying to wrap up my PhD on tree biodiversity in the Andaman Islands. But in the meantime, I've been working on some cool projects with the Season Watch team. And today I'm going to share a story that we've been working on to be published in a popular science format called A Malayalee Mango Mystery. And I hope you'll enjoy this talk. Before we jump in, I wanted to thank the three partners of Season Watch, NCF, Wipro, and NCBS. The work I'm presenting here today has been possible in large part through Season Watch's partnership with Mathrubhumi Seed and their incredible network of school teachers across Kerala who have been consistently collecting data over the years. So, summertime is synonymous with mangoes in many parts of India. Growing up in Kochi, mango trees in our backyard would flower in January or so, with unripe fruits in March and lots of ripe fruits roughly in April, which is summer vacation. So this is an important emotional marker for all of us. But recently, people have been observing the timing to be a little inconsistent. Annama teacher from Pathanamthitta reported that this year she saw lots of flowers on 2 mango trees even in July. Prabhakaran sir from Kannur said that mango season has been late this year for them. And just outside Kerala's borders, in Madurai, Dr. Aruna Chellaya said that 2021 has been a strange year for mangoes in her home. This was about the timing of flowering, but there's been some concern about the amount of flowering, and that is to be changing as well. Mango farmers have been linking excessive rainfall years to years of excessive flowering in mangoes as well. So there's some inconsistencies here. And when it comes to a problem of such national importance, because mangoes are kings of fruits after all, who will investigate such a case? Surely this needs more than one person. So Season Watch, a group of citizen scientists or ecological detectives, they decided to step in. Season Watch is a group of ecological detectives who collect detailed information on fruiting and flowering phases of trees in India. They use this dedicated app to collect this information. That's pictured here on the right. And they do this to understand responses of trees to climate. Many ecological detectives who work with Season Watch are school children, and they work with teachers from their school as part of nature club activities. Season Watch detectives may be young, but they're not inexperienced. In the past, they've solved confusing cases like that of the Kanikonda flowers, which you may have heard of. We also decided to look at Kerala observations because most Season Watch observations are from Kerala. The bar represents the number of observations from each state, and Kerala really outweighs contributions from many other states in India. And also some events that have been that looked at mango flowering at different times of the year showed that Kerala has some trees that are flowering pretty much whichever time of year that you're looking at, which is a bit unusual. So, but before we began our observation, we had to check, before we began our investigation, we had to check whether we had the power to make inferences. The litmus test for power is sample size, and we need hundreds of observations at each time point to be able to say something for sure. Naturally, we decided to look at weekly scale data. Season Watch trees are observed once every week, and this is a natural start point. But we saw that there were some irregularities in some of the trees. Some places, some people sometimes don't observe trees very regularly. So there were some weeks where the observations were very low in number. So we had to aggregate it to fortnightly scale so that we had enough number of samples. All the things that we present right now, going forward from here, are at the fortnightly scale. So using fortnightly scale data, we looked at when peak flowering happened in Kerala. When I say peak flowering, I mean when did maximum trees have many flowers. So this peak flowering between the years of 2014 and 2021 shifted between 4 months, January and April, which we think is a large range. 2016 had the lowest peak over here in April. And then, 2016 had the most delayed peak in April. We then looked at the amount of flowering, what proportion of trees were flowering at this peak. Between 2014 and 2019, you can see that the proportion of trees that were flowering, this border between yellow and green, is shifting upward a little bit. But in 2020 and 2021, these 2 years had much lower flowering at their peak across Kerala. Now that we know that there's some patterns, we need to know who or what is driving these patterns. For season watch detectives, climate change is our arch nemesis. Under the climate change umbrella, a lot of chaos happens, but through temperature change, rainfall change, sea level change, or extreme events like cyclones, storms, droughts, and fires. Many detectives often jump to conclusions between nature and climate because there's a lot of chaos happening. But season watch detectives know a little better. We wanted to line up all our suspects and then systematically eliminate them. So our first suspect here was mango varieties. You know that in India there's hundreds of mango varieties, and they could have really different behaviors in flowering and fruiting. This is what could be driving the patterns across the years. But unfortunately, Season Watch does not record detailed observation on varieties. We had to ask our season watchers for some insights. And my teacher from Pathanamthitta and Prabhakaran sir from Kannur are avid naturalists and also consistent season watchers. And their intuition was that grafted or hybrid varieties, which are unusual in itself, would have different behaviors. But what they saw was that even local varieties that were present in their locations were showing untimely behaviors in flowering. So what we concluded was that variety may not be our prime suspect. It may be an important factor, but it's not a prime suspect in this case. We then moved on to our next suspect. We wanted to see if the patterns we were seeing were because of geographical variation. Simply speaking, flowering starts in the south and then moves northward. Were we looking at trees in different parts of Kerala each year, and was this what is causing the patterns that we were seeing? To do this, we had to track down the location of each tree that we observed. Seems simple enough. There's an app that is tracking the location of each tree that is being observed. So we should just be able to use that data. But unfortunately, this turned out to be quite a task. The app wasn't recording the locations properly, depending on the weather at that time or the sensitivity of the phone or the app at that point. And when we mapped out all the trees in Kerala at the global scale, what we were seeing is that trees that were supposed to be in Kerala were showing up in different continents, like all over the globe, somewhere in the middle of the ocean, which was completely unreal. So we had to use some cool tools that were built on Google Maps and Google Sheets called Awesome Table Geocode. And what it basically does it uses the address of the school that it is being observed in, and then looks it up on Google Maps, and then uses the latitude and longitude and puts it together on a sheet. Very neat way of doing that without having to do it manually. And once we did all of that and we kind of, brought back home all the trees that were dispersed across the globe, we found that geography was not what we should be most concerned with. Because every year, the different locations across Kerala were being observed fairly similarly. It was not that one year there was like a northern bias and one year there was a southern bias. We were fairly consistent. So finally, we had to confront climate. We had to decide now where to focus our energy. There's a lot of chaos happening under the climate umbrella, right? So we decided to take a step back and consider our subject here, the mango tree. This is an inland tropical tree species. And like many of its kind, it is hugely influenced by rainfall patterns. So we decided to focus on that for now. And our other clue was that, rainfall has been variable in Kerala over time. Since 1901, Kerala has been getting drier, as you can see from the downward trend of this graph of total rainfall. But how do we look at rainfall events? How do we decide how rainfall is causing these differences? Do we look at single events in rainfall? Do we look at the difference in amount of rainfall over different years? Or do we look at accumulated effects of rainfall over a few months before flowering? If you think of this like a murder, did someone stab it? Did someone use slow poison? What is the cause here? We decided to look at total rainfall in the previous year, which, just as a broad thing, and also northeast monsoon, which is the rainfall season right before mango flowering, and also winter rainfall during mango flowering. We saw that total rainfall and northeast rainfall didn't have any patterns with the mango flowering observations that we saw. But on the other hand, winter rain was really high in 2021, and that could be what is that caused the low peak of mango flowering this year. This was the only nugget of wisdom that we were able to derive from this entire exercise. And really, this is not the aha moment that we were hoping of, like nicely wrap it up with a bow and we're done with this detective story. But instead, we did learn a few things. What we learned was that we need more eyes on the trees. We need more detailed observations, consistent observations to understand what's going on. But also, we need to be working with climate detectives to get a nuanced picture of how trees and climate are linked rather than understand things broadly. So we hope to be doing these things in the future.
So hi everyone. Thank you, Krishna, for the great talk. And I'm just wondering whether if you have any questions. I don't see any questions from the audience yet. So Krishna, can I ask you a question right now?
Sure. Hi, Kaveri.
Hi. What made you to think of doing this study?
Actually, I mean, some of this was personally inspired because I think during the lockdown, I was home in Kochi after a really long time. And it was the first time in like 10 years I was spending, more than 6 months at home. I mean, actually more than a month at home at a stretch. And I got to observe a lot of the things in my backyard as like an ecologist, not like a high school student. So I mean, actually personally noticed some differences in the trees that I remembered. And I approached Geeta and Swati with some of this, and they were very supportive. They were very happy to let me use some of the data and see if there's wider patterns than just my backyard. That's mainly it.
So one more question from me.
Sure.
So do you want to continue working on the mangoes, or do you want to continue on other season watch project or any other of the city science site project?
Actually, I think there's more to explore with just the mango itself, because although the results we presented here was the broad scale that we were looking at, we also got some really cool insights from the people we talked to and from some climate people we talked to, that the sense we have also is that climate effects may not we may not be able to observe them at a broad scale, but there may be like, smaller micro scale differences in what's happening. And it may be important to explore, say, urban versus rural differences. Or what people were talking about was that roadside trees were responding in their experience very differently to things that were further away from. So there's some patterns that there's a lot to explore just within this itself. And we also chose mango. I mean, there's reason to choose a mango besides this, because Season Watch also has plenty of mango trees that are being observed. So it's one of our largest data sets as well. I would love to look at other trees and other landscapes as well. I'm hoping the Andamans contributes more data soon. For example.
That's great. I'm really excited about your work right now, and also thinking that it would be great if you could get some oral history data on the mangoes. Talking to people if you have collected any of the data. And the other thing also, in order to see changes in the landscape, you may be able to check on some projects that are using 360-degree cameras to collect the data on the environment. So that way you can compare between years if you have 360-degree cameras pictures. Maybe that's one of the options. So
thanks.
That's great. That's great. Thank you. Any other questions from the audience, I don't see here any. So I guess
there is one question from Nishant Kaberi.
Okay. Where I don't see in the chat.
It's on the chat.
Okay. Okay. Yeah. I see the question now, Nishant. Are you planning such study for other species in Kerala or any other states too on mangoes? Yeah, that's what I was thinking too.
I mean, we are with Season Watch. I think Geeta, Swati, and Sai will be able to tell you that we are Kerala is our biggest contributor, and thanks to Nizar, you heard Nizar's talk yesterday. So we are specifically sample size from other states. So if any of you are able to, mobilize support and get more data in, we would all be very happy to look at that for other states. But yeah, possibly some other species. If you have suggestions, I love playing around with data, and all of us do. So if you have suggestions, would be happy to look at patterns.
That's great. I'm thinking of actually Calcutta, West Bengal, because there are tons of mango trees, and my house itself has like 4 or 5. So maybe we can start doing something here. Okay. Yeah. Thank you. I'm going to now, thank you again, Krishna. I'm going to now to Ashwin. Thanks. Ashwin. Ashwin is a researcher. Yeah. Hi, Ashwin. Can I see you here?
Okay. Yeah.
So I'm now going to introduce Ashwin. Just a sec. Ashwin works with Bird Count India and encourages birdwatchers to document and monitor birds. Ashwin's previous research has mostly focused on plant ecology in the Western Ghats and in Northeast India. But over the past few years, he's been increasingly interested in and became aware of the power and possibilities of citizen science, mostly because of his long-term interest in birdwatching. So now here it is, Ashwin, to you to talk about your research.
Hello, everyone. My name is Ashwin. Has been studied, and among the most popular nowadays is the use of satellite tags and rings and flags, both of which require birds to be captured. So these are resource intensive and expensive methods. There's also the use of radars, using which you can look at the overall intensity of birds that are migrating over any point of space during any day. So this map shows that in eastern US, on the night of September 1st, 2021, there was intensive migration through that area. Just like radar, is it possible to track migration through observations of birdwatchers? So birdwatchers are present all over the world, and they upload their observations with a date, time, and location stamp to global platforms such as eBird. So this is the distribution of barn swallow across the world. This is the distribution of barn swallow during the summer. And this is the distribution of barn swallow during winter. And as you see from the observations of birdwatchers, you can simulate migratory movement. So using this concept, is it possible to simulate migration and create migration maps? So we downloaded eBird data for each of 70 bird species. We generated snapshot bird distributions at regular intervals throughout the year. We stitched them all together into GIFs. And we also plot frequency charts that track the commonness of these birds through seasons. All of this was done using the software R. So using this, we have a simple tool to be able to get insights about migration and get global perspectives about migration that were not possible previously. Migration of common cuckoo. Common cuckoo breeds across temperate Eurasia, also on parts of India and the Himalayas. and it winters largely in Africa. So the entire global population winters in Africa. So what you see here is all the African birds are going straight down to South and Central Africa, whereas the East Asian and Indian birds are passing through India. You can see passing through South India in large numbers and moving to Africa. You see this moving line at the bottom right corner. That moving line takes you through the times of the year and through how frequent it is during these different times of the year within India. From April to June, July, the species is encountered most often in India. And this is because in the breeding areas, they're vocal. And then again, you see from October to November, they're quite abundant. They're encountered frequently in India because they're passing through in big numbers. So first, I'll show you an example of migration within the subcontinent. And there's no better species for this than Indian pitta. Indian pitta breeds in central India and North India, even the Himalayan foothills, and almost the entire peninsular population winters in the south. So if you see, this is the breeding area. And now as the winter sets in, they're all down in the south and in Sri Lanka. So get a perspective, a countrywide perspective of where Indian pittas are going. This is all from the observations of birdwatchers. Now an example of a bird that breeds in the north and migrates south for winter. And this is quintessential migration. You'd all have heard of migrating south for the winter, this phrase. So this is Blythe's warbler, a bird that is there in many of our gardens in the Indian subcontinent during winter. The entire global population from across Eurasia winters in the Indian subcontinent. And this is a perspective that we did not have before these maps were created, that we are global custodians for this species during winter. As you can see, they all gather in India, and then you have them spreading out across Eurasia. What about a species that breeds in the south and migrates north for the summer? The Pallas fish eagle does exactly that. So now if you see during the summer, they're in Mongolia. They come to India during the winter, and this is when they breed. So they breed in Corbett, in Kaziranga, many parts of India, and then migrate to Mongolia to spend the summer, but they've already finished breeding. They migrate with their juveniles. Then passage migration into Africa. Now is actually the time for passage migration. Many birdwatchers will be heading to Gujarat and Rajasthan to see this wonderful phenomenon of birds passing through India on their way to Africa. And a great example of that is Amur falcon. But Amur falcon, it's not yet time for them to pass through. You see, they breed in East Asia, pass through Northeast India and Southwest India on their way to South Africa. But the time of the year when they migrate is more late October, early November, as you can see from the peak. European roller, on the other hand, is migrating right now. They breed in the Central Asian birds, pass through a large part of the Indian subcontinent on their way to Africa. They cross the Arabian Sea and go on their way to Africa. On the way back, not so much. They go directly. They sort of skip India. But as you can see, during autumn migration, they pass through India. Westward migration into Africa. Pied cuckoo. It's not passage migration. They come to India to breed. This is a very popular bird in our culture. But in the south, they're present year-round, as you can see. In the north, they come during the monsoon. They're known as harbingers of the monsoon. And during winter, all the birds in central and north India head back into Africa. Eastward migration into Southeast Asia and Australia. There was a great story recently of an oriental pratt-and-coal that was satellite tagged. It was caught in Australia, and then it was found to breed in North Karnataka, which was an amazing new learning because we thought migration was mostly north-south and backwards. White-throated needledale is another bird that does exactly this. It breeds in the Himalayas and many parts of East Asia, and the entire global population winters along the east coast of Australia. So you have this bird going across Southeast Asia all the way to Australia every year. Opposite migration from the south to the north. Wilson's storm petrel. This is a bird that breeds in the Antarctic. Birds that breed in the Antarctic breed during our winter, their summer. And then the entire population comes up all to the northern hemisphere during our summer and monsoon, as you can see. And now they go down. And during winter, when it's cold for us, it's summer in Antarctica. You can compare migratory routes using this method. So there's Isabelline shrike and brown shrike. Isabelline shrike breeds slightly westwards of brown shrike, and even their wintering ranges are similar. Isabelline shrike winters in Western India and in parts of Africa and the Middle East. Brown shrike largely winters in India and Southeast Asia. And you can see this wonderful separation both in breeding ranges and in wintering ranges. Tracking new migratory routes, like for yellow-browed warbler. Yellow-browed warbler is an amazing bird that previously used to winter mostly in India and Southeast Asia, in Northeast India. But now what we see is that increasingly yellow-browed warbler has started taking a westward migratory route. A large number of birds pass through Western Europe, which didn't happen in the past. Where do these birds go? Do they come back along that route? They don't seem to come back along that route. Do they all perish? These are all questions that are still open. Some interesting phenomena. Arctic warbler. Arctic warbler has continuously expanded its breeding range westwards, but it's retained migratory memory. They all winter in Southeast Asia. But now what happens is the birds that winter all the way, breed all the way in Western Scandinavia, continue to go across Eurasia before coming down to winter in Southeast Asia. They haven't changed their wintering grounds. And exactly the opposite is with northern wheatear. They've expanded their breeding range eastwards, but the entire global population continues to winter in Africa. And these are wonderful new insights. And some new learning and questions. Black Cap Kingfisher, we didn't know whether we had birds that remained in India during the breeding season. Do they also breed within India? This migration map shows that they're almost entirely winter visitors to the Indian subcontinent and to our coast. And this is a species that is greatly declining. So we need to understand their winter habitat and conserve their winter habitat along the Indian coastline. Chestnut-headed beater, there is a population in the Western Himalayas that breeds in the Western Himalayan foothills that disappears during winter. Where do they go? Do they come down to the south? Do they go to the Eastern Ghats? These are still open questions. And these are questions that come out of such. All the code. Many thanks to birdwatchers and eBird editors who have made this possible. And thanks to all our funders.
Ram and Nishant. So one comment from Ram is that it's about he wants to see stuff like this with pied thrush.
Yes, I'll try and make one with pied thrush. So sorry. Yeah.
Go ahead.
So I just wanted to say that there are a number of species for which we still have to try this. But it's slightly lacking in data in the breeding areas, especially in the Western Himalayas. So pied thrush is an example of that. So hopefully over the next year or two, as more information comes in. Yeah.
And then Nishant says that it's nice perspective. And okay, that's great. I loved it. And then another question from Ram. He said, yellow-browed warbler, any idea about this and why? Crazy, any idea about this or why?
Yellow-browed warbler is actually one of maybe 5 or 6 species now that are at least 5 or 6 species that were once upon a time considered Eastern migrants from the Eastern Palearctic down to Southeast Asia, Northeast India, these areas. But they're increasingly being found in Western Europe. And the thought is that there are more and more individuals every year that are following a westward migratory route. So is this because of climate change or some other reason? But I think many researchers in Western Europe are trying to address this question. Olive-backed pipit is another similar species, Richard's pipit. All of these birds have, there are more and more individuals being found every year in Western Europe.
A question from Farida. Do these graphics contain both satellite tracking and citizen science uploads?
These are only observations by birdwatchers, so only citizen science observations.
Okay.
Yeah.
Hey, I have question.
Yeah.
Have you seen anything? Do you have any of these graphics for greenish leaf warbler
Yes,
or
yes.
any other leaf warblers?
So we do, and there's also a nice comparative graphics of green and greenish warbler together.
Oh.
So all of these are uploaded on the Bird Count India website. There's a section called Migration Map, so I encourage everyone to go there and explore. It's only 70 species at the moment, but I think nice migratory routes to view.
Oh wow!
Yeah.
I must tell this to Madhukatti about the green leaf warbler and greenish leaf warblers. Okay, any more questions? Okay, I think that's about it. I'm going to thank you again. I'm going to now move to next speaker. Thanks again, Ashwin.
Thank you so much.
Okay, our next speaker is Maxim, and I'm going to talk a bit about Maxim. Let me switch to my other window. Okay, hi Maxim. So Maxim is here. He's been working with citizen science projects for years, and he's focusing primarily on birds and working with also birds and other fauna. He's also interested in working with children, engaging public in science. Most of his work focuses on Kasaragar in Kerala. He holds a master's degree in marine geology. Wow, marine geology from the University of Bangalore. Maxim currently works with Bird Count India and serves as the state coordinator for the Kerala Young Birders Network. Prior to this, he was coordinator of the Kasaragar Bird Atlas project. That's great. Thank you, Maxim.
Hello everyone, I am Maxim Rodrigues and I will be speaking about the joy and tears of digitizing historical bird data. eBird is a powerful tool used by a large community of bird watchers across the globe. It acts as a digital diary to keep records of bird observations. It was launched in 2002 by Cornell Lab of Ornithology and later in 2014 it was popularized in India. Today India is one of the greatest contributors to eBird in the world. So far in India, 26,000 of birdwatchers have uploaded around 1.2 million of checklists in eBird. This includes records from many birdwatchers who have uploaded their 30 to 40-year-old observation from their notebooks. This is how an eBird checklist looks like. This is a very old checklist that dates back to 1865. You must be wondering that just now I said that eBird was popularized in 2014 in India, and then how is that such an old list from India is seen in eBird? Who could have uploaded this observation in eBird? Before I answer that, let's understand what does historical data mean. In a broad sense, historical data here is basically information gathered about birding events from the past. All data before year 2012 is referred as historical data. Let me take you through how we uploaded historic observation in eBird. First, we contacted the veteran birdwatchers within India and also those abroad who had visited India. We requested them to send their bird observations from their old diaries or in any other analog or digital format. We also gathered data available in old publications. Informations were received in the form of notes made in the field diaries, sketches, and some were already in digital format. We entered all this information in Microsoft Excel files and finally transferred them in eBird through an option called import a file. Here you can see an example of how observations were made in notebooks. The observer has added location and date when the lists were made. We then digitized these in eBird. Data from publications such as trip reports checklists were also digitized. Data from some of the bird surveys reports in Kerala between 2007 to 2015 was also digitized. For example, about 150 checklists were uploaded from Aralam and Wayanad wildlife sanctuaries. This data dates back from 1900s to 2000s. We digitized checklists from north and south of India from Northeast India and from the Andaman and Nicobar Islands. More than 3,000 of checklists from 30 plus birdwatchers were digitized and uploaded in eBird. Thanks to all birdwatchers who have contributed their historical bird observations. Now, why it is important to have historical data? Before that, it's very important to understand how eBird data is being used. It's mainly used for research and conservation. One can find species occurrence, spatial distribution, and changes in population in a given location over a time. What are the benefits of having all this historical data? Through historical data, we can get a picture of the changes in bird populations in the past and contrast it with the data available in the recent years. For example, Pacific golden plover. It is an Arctic breeding shorebird that winters in South and Southeast Asia. This species' historical abundance has decreased in several wintering locations, possibly due to the effects of climate change in its Arctic breeding habitat. This information is derived from the State of India's bird report that has based on eBird data uploaded before 2012. Such kind of historical data helps in understanding the pattern of long-term trends. The graph here shows 5 different species of vultures in India that are showing strong long-term decline. We must heard that, or we must have seen in the field that most of these vultures were very common in the past. These long-term trends are derived from eBird data, and all the data available for before 2012 have been digitized from birdwatchers' notes. Although for a few individual species there may be long-term studies, for the vast majority species historical eBird data is the only way to assess long-term changes. We faced a few challenges while digitizing the data. A lot of species have gone through one or more taxonomical changes in the last few years. This resulted in name changes for the many species, while some of were easy to find, but for others we had to refer to old field guides, publications and websites. A few experienced birdwatchers were able to help us in this. We also had spent a lot of time getting the location right because some of them did not exist anymore. For example, Mandakini bird camp in Uttarakhand, and it was informed that the original camp was washed away in 2013. Some locations were spelled differently now than what it was called in the earlier. For this, we took help from the regional volunteer eBird reviewers in India. Some handwritten notes were very hard to interpret, and we had to try various methods. While working on this project, I learned about many bird species from different landscapes, learned some old interesting names of the birds, and also got a taste of how historical birding is used to be like. I also got opportunity to interact with the veteran birdwatchers and to listen to their field stories. It was really inspired to go through some of detailed notes made in the field diaries. Let me share one of the most interesting observation of my life. If you look at the year of the list carefully, you would notice it's from 1971, when India was at war with Pakistan. And this observation of Sarkir Malka was done by Lieutenant General Baljit Singh, who was an army officer, and he was a part of this war. He was crossing the bridge at Aknur at the same time missiles and bombs were coming from other side. He soon moved into Sarkanda bush nearby, and where he found this Sarkir Malkoha. This kind of historical information is fascinating. I would recommend everyone to please read this interesting account. Although I enjoyed digitizing data, there were also frustrating times, especially dealing with a particular data set. I think I may have spent a lot of money having tea and coffee to stay awake and complete the work. However, it has been an interesting journey for me, and I'm sure it might be the same with Harisha and Ishita, who also helped in digitizing. We thank Bird Count India, eBird and Cornell, eBird reviewers, and all bird watchers who have generously contributed their notes. Thanks also to a number of groups and organizations for financial support over the years. Thank you for listening. Thank you.
Okay. Thank you, Maxim, for this talk. There are no questions yet, but there is a comment from Farida. The question is, comment from Farida is that, wow, this requires passion, dedication, and patience. Wish this has happened for other taxa too. eBird does amazing stuff. And then also a couple of more questions. So thank you.
So there is one from Saundarya
Yeah, there's one more question from Saundarya Valley. It says, how big is your team? How can people join in such research work of yours?
So we are done from Bird Count India team. So we collect historical data from which are available from the different bird watchers in different parts of the country. We still believe that there are many notebooks that are available with many bird watchers. So if we get all those data, we'll be happy to digitize them all to eBird.
Wow, that's fascinating. I'm just also wondering whether, again, coming back to the oral history, have you thought about collecting narratives, talking to people and recording them, and then maybe digitizing them? Collecting oral history data. Have you thought about collecting oral history data from people, like, interviewing people, birders who are been doing birding for a long time?
Yeah, they have, like most people have their observations in notebooks, or a few people at bird watchers had their observation in Excel sheets. So we contacted them through we discussed them through phone calls or emails, and they were happy to share all their observations.
So do they have any stories to tell you? Do they have stories to tell you when they give you the data? Do you collect those stories?
Yeah, when I just discussed to them, they I also asked them some stories which they had during their bird watching in like 30 or 40 years back, and it was very interesting to listen to their stories.
Great.
The different places they visited. Even yesterday, I had discussion with Captain Praveen Chopra, who had shared me great data. Like more than 1,000 checklists were digitized from his observation.
Wow.
Yeah, still I'm in contact with all these people. So it's nice to. He was yesterday discussing about his last year's trip to see Great Indian Bustard in Rajasthan.
Wow, wow, that's wonderful. One more question from Jagan. He says, are you planning to do for bird sightings from all the publications?
Yes. We also done digitization for some of the publications which were available. If we have more data, definitely we'll be happy to do that.
That's great. That really requires a lot of passion and patience. Thank you.
Yeah.
Oh, and there is one more thing. Jagan also says he wasn't aware of this group account. He wasn't aware of this group account. He says that he wasn't aware of this group.
Oh.
Of this group account, sorry.
Okay.
So now you know, Jagan.
Yeah.
Okay. Thank you, Maxim, for wonderful work. Hopefully we'll hear more about your work in the future.
Yeah, thank you so much for this opportunity. Thank you.
You're welcome. So now on to the next speaker. Should we move to the next speaker? Okay, Suneha. Hi, Suneha. Hi. So next speaker is Suneha Jagannathan. She's going to be talking to us about involving divers in citizen science. So Suneha is a research affiliate at Dakshin Foundation. She's sorry. my voice. She's the program coordinator for Reflog, a citizen science program by Dakshin Foundation to monitor marine ecosystem. As a marine biologist, Suneha often finds people lack understanding of ocean system and believes that citizen science is an excellent tool to bridge the gap between oceans and people, which she is attempting through Reflog. So that's great. Thank you, Suneha. And here you are talking about your work on citizen science.
Hello, my name is Suneha and I'm a research affiliate with the Dakshin Foundation. I'd like to talk to you all about a project that we're working on titled Reflog, involving divers in citizen science. Now, Reflog is a marine citizen science program aimed exclusively at scuba divers. Recreational scuba diving in India today is conducted across the east as well as the west coast of India, including the Andaman Islands as well. It is well documented in literature that people engaged in a sport that is set in a particular ecological context tend to be more invested in the conservation of that ecosystem. Now, following that rationale, we plan to enlist scuba divers in a marine citizen science program. Reflog was first conceptualized in 2016 and piloted in the Andaman Islands. The program was tested with dive professionals to strengthen data collection methodologies, as well as liaise with dive companies to understand their strategies to implement Reflog seamlessly within the services that they offer to their clients. Our overarching goal with Reflog is to increase ocean and scientific literacy. Now, using the medium of citizen science, we also plan to collect data on marine species populations. In order for us to effectively do this, we plan to create effective environmental education tools. And finally, our final goal with the program is to engage the adventure sports community in the country in the conservation sphere and encourage responsible tourist behavior. We use structured surveys to collect data for the Reflog program. Our rationale behind this is twofold. Firstly, it allows us to simplify survey techniques to our non-scientific participant base. And secondly, structured or semi-structured surveys are known to increase the accuracy of reports and potentially reduce biases in data. These underwater survey slates are designed to be able to be taken by divers during their dive and marked out with a pencil. Now, considering the vast habitat diversity in India, we need to customize the Reflog survey slates according to each location. We select a set of 12 fish and 12 invertebrate species per location, and the ones that you see on your screen here were designed for the Andaman Islands. We limit the number of species to 12 as the time spent on a dive is rather limited, and we don't want to overburden our participant with too many tasks to follow. Now, each of these slates have accurate illustrations of all survey species, which allows for easy identification. Participants are expected to tally occurrence records of each of these species that they observe on a Reflog dive. In addition to species occurrence, we also plan to collect important ecological and dive log data. Dive log data basically tells us the amount of time that the participant spends during their dive, which gives us a basic idea of time spent during the survey. We also collect crucial information on dive site descriptions, which sets an ecological context to the data that we collect. Now, considering the fact that divers are rather excited about larger species and need to engage with this behavior of theirs, we also collect information on large pelagic species such as barracudas and rare and charismatic species such as marine mammals, sharks, rays, and turtles. Now, of course, we are limiting the number of species per dive, but there is a rationale behind what species end up on each Reflog survey slate. Now, firstly, the species need to be easy for a diver to identify, particularly divers who are not very experienced in species identification. And secondly, they also need to be, it's important that these species are not easily confused with other species that are similar looking in a particular region. Secondly, we want the species list to be representative of across the food chain and various trophic levels. Now, a third criteria that we use is to select indicator species, which can indicate anything from fishing pressure to pollution levels of the ocean. We also want to include commonly seen species for divers, but not overabundant species. It would be rather difficult for a diver to be able to count 50 individuals of a particular species. Now, finally, the species list needs to be representative of the region that we're building the list for. Now, species lists are shortlisted by the program team and then undergo consultation from the diving community as well as the marine ecology community in the country. All data that is collected through the Reflog dives will be uploaded by participants onto our website, which will be launched by the end of the year. Now, through our website, we allow users to contribute the data that they collect through Reflog, but also provide information about dive companies who are currently partnering with us to conduct Reflog dives. Another aspect of the website is to provide information on how dive companies can potentially collaborate with our team to develop Reflog for their location. We plan to visualize data in interesting and easy to understand manner for our website visitors. Raw data will be provided upon written request to the program team. Now, since Reflog relies on participants with a specific skill such as diving, we require two levels of engagement. Firstly, with dive companies and dive professionals who act as facilitators for the program. And secondly, with the recreational divers themselves who are the end participants of the program. The Reflog program is only open to certified divers who are comfortable in the water and with their equipment in order to ensure that the program is conducted in a safe manner. Now, dive professionals are trained on Reflog survey techniques and species identification skills. We expect that the dive professionals pass on the knowledge to the students that end up diving with them. Recreational divers receive training manuals as well as educational aids. Now, Reflog is intended to be a program that can be used as a stepping stone for people who don't have a background in marine biology or conservation. Keeping that in mind, the program is intended and designed to maximize ease of use and minimize intervention from biologists on a day-to-day basis. Keeping this in mind, we use educational tools like training manuals to train participants on survey skills, species identification, as well as the rationale behind citizen science. The main limitation, of course, of a program such as Reflog is that it's rather limited in its reach, considering the fact that scuba diving itself is a pretty expensive sport in India. Forging the way ahead, we hope to launch Reflog in the east coast of India by early 2022. And over the next few years, we plan to collaborate with dive centers across the country, as well as beyond the Indian subcontinent, and hopefully have a presence across the Indian Ocean. Thank you very much for listening to my presentation. I'd definitely like to thank the many divers and biologists who graciously donated their photographs for us to use. And I also would like to thank our excellent design and visual design and art team. And finally, all the biologists and the dive community who engaged with us to help design the Reflog program. Thank you.
Thank you again. Thank you, Suneha, for the talk. Really loved the talk. So I'm looking if they have any questions. I don't see any questions yet.
We have one.
Oh, we have one.
Kaveri.
Okay.
Yeah.
What are the geographies that you are covering for your work is the question.
So we had earlier developed slates for the Andamans. That was the first initial phase of the project, which was back in 2015-16. Now we're currently developing our Reflog resources for the East Coast. And hopefully we plan to have a presence, as I mentioned in the presentation, across the Indian coastline and hopefully at some point beyond that as well.
So there's one more question from Nishant. It says, how will you rectify the case of repeat counting by divers in the same group? Is there a possibility for errors in counting?
See, yes, we do acknowledge that there could be a possibility of errors in content. That is something that we will be dealing with in the dive instructor level. So these are the things that we will be training the dive instructors upon in terms of the most basic concepts of a survey is don't repeat a particular area more than once. So those are the things that we'll be dealing with in the dive center and the dive instructor level, and hope for that sort of knowledge to pass on to the end users, which are the recreational divers who are customers for these dive centers.
There's one question from Jagan. Any plans to expand this from to local fishermen?
As of now, our sort of target is to work with the adventure sports community, because there is a clear interest and willingness to engage within the adventure sports community. So it's very easy for us to start off here because that traction sort of already exists. But hopefully, once we've sort of come to a point where we've gotten to a level where our data collection techniques and our management protocols are set in place, and we can say that we've sort of successfully covered a particular community, that itself is likely to take quite some time. Only then will we be able to move on to another sort of target group, which could be other sports, for example, like surfers, and then other communities invested in the ocean, like fishermen as well.
So I have one question. Given that it's a citizen science stuff and you are training the divers, how long does it take to train them, and what's the time or effort goes into it? Can you please tell us that, the background of how things work?
So to give people who are non-divers in this platform an idea as to what I mean by a certified diver itself, typically a diver needs to go through a 4-day training program where they already need to have basic levels of swimming and floating skills, and then they go through a 4-day sort of training program under any certification agency to be able to be certified as an open water diver. And now beyond that, they can sort of take more and more courses to sort of advance their certification to another level, take up multiple specialties as to what they prefer. So those are not really our prerogative. That is already being handled by the diving education community itself. Now, the Reflog program is not expected to be something with a very lengthy training process. What will take us time is for us to liaise and train the dive instructors. That is something that we expect to have regular engagement with, because in a lot of dive companies in the country, there's a regular turnover of dive instructors. Every few months, you get sort of new professionals who are entering a company. So that is what we believe will take up most of our sort of engagement as a team. And for the dive instructors themselves to train their clients or customers or students, whatever you want to call this group, that is not something that we expect to take a lot of time, simply because the slates itself are designed to be rather self-explanatory and not something that requires too much of orientation to do. They would require, what we expect is to have a detailed briefing, which anyway occurs before you take a certified diver out for a dive. You are expected to brief them about the local dive conditions, the local dive protocols. This is the area where we expect Reflog to be incorporated, is within that briefing, to give them an idea as to why, what Reflog is, what they'll be doing on their dive, a quick run through of species that they would see. So that's sort of the 2 levels of engagement that we see, and the amount of time required for both of that.
There's one more question from Mittal. It says, what are the incentives for divers who collect data? Is there any dashboard maintained where they can see their names, or and what all they have documented?
So we've not.
So 2 questions.
Yeah. Thanks, Mittal, first of all, and hi. It's been a long time since Mittal and I met her when I was a volunteer at Craft Bank.
Okay.
So we've not come to the point where we've launched the website yet. So we don't have at the moment a leaderboard that's put up on the website. But what we do plan to have is a sort of a grading system. So you do a certain number of Reflog dives, and you get a particular sort of a certificate on your user profile on the website, saying that you're a grade A or a grade B or a grade C or something. I mean, we've not focused on those names as of yet, but what we are thinking about is a grading system, not necessarily to compare each user to another, but more to encourage each user to sort of push and continue with Reflog on their own regard. So that is sort of the incentivization that we hope to provide over the course of the next year once we launch the program.
One question from me. So we all talked about, engaging locals and local communities and stuff like that. A project like this actually looks like have real, great opportunities to engage local communities. So my question again is that diving is an expensive process, right? It takes a lot of effort, money, everything. So how do you engage the local people? Do you engage local communities, or the divers are coming from outside?
So I think this is a pretty large answer. So yes, the limitation of a program which involves a community like divers itself is by nature, it is not the most inclusive program. Diving is, like you said, an expensive sport. It's not something that's accessible to most people in the country. So on that level, there's a few things that can be done. So I believe that for us to make citizen science for divers more inclusive, diving itself needs to be more inclusive. So I do believe that dive companies in each location are trying to put in more efforts to offer their training services at a lower cost for people from local communities or the fishing communities in the area in which they operate. So that is sort of a systemic way in which we can bring in more people from those particular geographical contexts into the dive industry itself. Of course, it's a very, very slow and long process, and it's not something that's going to happen immediately. So that I would say sort of engaging with local communities on the level of a dive center itself needs to happen first, and it's already sort of happening slowly but steadily. And then once that happens, then by nature, Reflog itself becomes a more inclusive program. But like I said earlier, like our hope is to engage beyond just the diving community over time. Once we've sort of come to a point where we know what we're doing with the diving community and we've strengthened all of our protocols, then we do hope to expand beyond just that and have a sort of a more inclusive model of a program such as this.
Okay, thank you. I have a couple of more questions, but I can ask you later. So we are wrapping it up. Thanks, Suneha.
Thank you so much. Thanks for the opportunity.
Thank you. I am wrapping it up now. And so thank you all for joining us. We'll be taking a break now, and we'll be back at 2:30 with our last set of talks, which will be followed by our closing session of the conference. Thank you again.